Let's solve some problems on gas laws. We're given here some problems on ideal gas law. Oxygen gas is collected at a pressure of 123 kilopascal in a container which has a volume of 10 liters. What temperature must be maintained on 0.5 mole of this gas in order to maintain this pressure? Express the temperature in degrees Celsius. So to solve this problem, we use the ideal gas law. So the ideal gas law is just PV equals nRT, where P here is the pressure, V is the volume, N is the number of moles, R is the gas constant, and T is the temperature in Kelvin. So the value of our gas constant R here that we're going to use is 0.0821 atm liter per mole Kelvin. We're given here the pressure, which is in kilopascal. We need to convert that to atm. So 123 kilopascal is just equal to 1.21 atm, and our volume is already in liters, so we don't need to convert that. And then we have the number of moles, and now we can plug in all the values into the equation. So we need to find the temperature, to solve for the temperature. To do that, the temperature is just equal to pressure times volume over the number of moles times the gas constant. So temperature is just equal to 1.21 atm atmosphere times 10.0 liters over 0.500 moles times 0.0821 atm liter mole Kelvin. So atm here cancels, and liters 2 cancels out, and then the mole units. So we're left with Kelvin, which we will convert to degrees Celsius later. So this is just equal to 294.76 Kelvin. So to convert this to degrees Celsius, we just have to subtract 273 Kelvin. That is 294.76 Kelvin minus 273.15 Kelvin. So our temperature in degrees Celsius is just equal to 21.6 degrees Celsius, or approximately 22 degrees Celsius. Okay. How many moles of chlorine gas would occupy a volume of 35.5 liters at a pressure of 100 kilopascal and a temperature of 100 degrees Celsius? After determining the number of moles, calculate the number of grams of chlorine contained in this container. So we're already given the volume, the pressure in kilopascal, and the temperature in degrees Celsius. So we need to convert the pressure to atm and the degrees Celsius temperature to Kelvin first. So our pressure, which is 100 kilopascal, this is just equivalent to 0.98 atm. And then our temperature, which is equal to 100 degrees Celsius, we add 273.15 Kelvin. So this is just equivalent to 373.15 Kelvin. Then now we can calculate for the number of moles. Number of moles is just equal to PV over RT. Now we can plug in everything. So pressure is 0.98 atmosphere, and then the volume is 35.5 liters. Then our gas constant, which is equal to 0.0821 atm liter per mole Kelvin, and then our temperature in Kelvin, which is equal to 373.15. So atm here cancels out, as well as liters, and then Kelvin. So we are left with moles. And this is just equivalent to 1.14 moles. Now we are asked to calculate the number of grams of chlorine gas, Cl2. So we need the molar mass of Cl2. So molar mass of Cl2 from the periodic table, this is just equal to 70.906 grams per mole. So to solve for the number of grams, we just have to divide the molar mass or molecular mass by the number of moles. Multiply. So that would be 70.906 grams per mole. We multiply this by the number of moles that we got, this one here, and the number of the mole unit will be cancelled out. So this is just equal to 80.52 grams of chlorine gas. Okay, next. What is the volume of a balloon if it contains 3.2 moles of helium at a temperature of 20 degrees Celsius at standard temperature? So standard pressure. So standard pressure is just equal to 1 atm, and then our temperature here is 20 degrees Celsius, and we need to convert that into Kelvin, and this is just equal to 298.15 Kelvin. So let's solve for the volume. Okay, to solve for the volume, this is just equal to nRT over P. So our volume is just the number of moles, which is 3.2 moles, times the ideal gas constant, which is 0.0821 atm liter per mole Kelvin, times the temperature, which is 298.15 Kelvin, over the pressure, which is 1 atm. So mole here cancels out, Kelvin and atm. So we are left with the unit liter. So this is equivalent 77 liters. So the volume of a balloon, if it contains 3.2 moles of helium, is just equivalent to 77 liters.